Modern software development projects depend on build automation technology. This includes tools like Make for building C projects, CMake for building C++ projects, and Maven for building Java projects. Developers use these tools to automate the various phases of the development pipeline. These phases include configuration, compilation, and testing. The problem is that these build automation tools are themselves software, and so are of course vulnerable to software security attacks, namely pipeline poisoning attacks. One recent example of such an attack is the xcutils backdoor, in which attackers managed to inject a backdoor into the libelzma library, which was installed on millions of Linux machines around the world. And the way the attackers did this was unique. They did not modify a single line of source code directly because they had to sneak their commits past the project's maintainer. Instead, they added poisoned test case files to the project, test cases that were hiding malicious binary code, and then modified the project's compilation phase to extract this malicious binary code and link it against the project's normal source code to produce the poisoned libelzma binary. Now, thankfully, the US government is aware of issues like this and have presented documents like SBOM and VEX to alert developers about known poison dependencies. The problem is that SBOM and VEX documents only alert developers about dependencies which are already known to be poisoned, and therefore do not help developers protect against original poisonings from creeping into their own build. Therefore, to protect against these threats, I am presenting an approach called build phase isolation, in which we isolate or restrict each build phase to only accessing the specific resources it needs in order to execute. For example, for the xcutils backdoor, we would restrict the compilation phase to only accessing source code files, because normally a compilation phase does not need to access test code files at all. If we do this, the xcutils attack model becomes impossible to exploit. And this is not just theoretical. We've implemented this in a tool called Foreman. Foreman is 177 lines of Python code long. Foreman runs a project's build system to completion to generate its normal binary outputs, along with a log of what files each build phase of the system accessed. A user can then pass a specification file stating what files each build phase should have permission to access to Foreman, and Foreman will compare those specified permissions against the system's actual accessed files. If Foreman detects that a build phase accessed a file that it should not have permission to access, then it emits a permission violation error to the user. Using this approach, we were able to detect the 2 poison test case files in the xcutils backdoor. And we have published this work in ICSI Near 2026. I'll be presenting it in Rio this April. I hope to see you all there.